Welcome to the section 18 of the course of this persistent with C++ and Qt. Now we're going to test our Infix compiler and show how it works. So to test the Infix compiler, we will need to create a prop tree builder and a lex analyzer. I just advance in this way to make the video more shorter, and we also include the header Infix syntax analyzer. If you are wondering if what's the reason that I didn't include the prop syntax analyzer, is because the Infix syntax analyzer already had a reference for this kind of class. It's a class actually, so it's not necessary to duplicate the reference. It's actually, in this way, it's simple. So we create two objects to build the lex analyzer. We have also building our Infix syntax analyzer with a reference to our lex analyzer and our tree builder. In this way, actually, the arguments, the parameters are pointers. But you might remember the reference and pointers is some quite similar. It's not similar, but they are like brothers. So in this way, it's possible to do in this way. Well, redundant. And okay, the next step is to create a resource file. And the resource file, the objective of the resource file is to englobe all the resources that we will need to our project. It might be, for example, images. We're going to also need some text for instance, the knowledge base that we're going to create just right now, and a lot of stuff. We can also create attach videos, GIF, whatever. Okay, so to create a resource file, we just need to go to the project folder, add new, look at the Qt label, Qt resource files, and choose, put the name, and everything is done. So when this is done, the resource folder appears in this view, and if you double click, or maybe add new, no, it's not, open in editor, you can also see that there is some kind of window to manage all the resources that we have in our project. And the first step is to ensure that it's only a slash in the prefix, and we should add a file. And remember to create a folder called resources, and we have our knowledge base. So our knowledge base is actually just a text file. It's pretty simple, but in this knowledge base, we're going to allocate all the rules that we're going to use in our persistent project. So this is the main resource that we will need. This is we also need to be very careful writing this knowledge base, because some kind of any typo will make our work harder. So just be careful with that. In the knowledge base, for purpose of this video, I'm going to create just two rules, and show off how is working the compile function. So more cards implies more happiness. No. And more, don't forget the semicolon, please. Exercise implies more energy. it's worth to notice that we need to use underscores to avoid problems in the compiler, because our compiler doesn't support blank space between an ID. We can actually change that easily. It's up to you if you want to change it. And also let's see that you can play with this knowledge base. I mean, you can create rules that are more complex. You can add the rules that you want, but for this case we are just testing with 2 rules. Okay, so we're ready to start the compilation. Well, we are not ready. Well, we need to first to push the file using the lex analyzer push file function. I'm careful in this way. I spent days, complete days, trying to figure out the syntax, the how to write this part. I think that in the time that I tried, there weren't enough documentation explaining this. So the referral resource is 2 points slash and the folder with the name of the file. In this case, you don't have to put the .txt. It's not necessary. The push file, you can debug it to ensure that everything is okay. So you can press F5 in Qt, press F11. Oh, I screwed up. Forget. Let's try it again. Because the problem is that we need to put in the symbol, the breakpoint, we need to put it in this way, and just delete this one, and we're ready to debug it again. So F5, and just ensure that this if entries correctly, return true. Great, that's it. Return to the main.cpp and just put a branch. So after this, we just need to put if s.compile out compilation success. Just enough to make clear that everything is okay. We don't need to debug and do all the steps in within the compile function to make clear that the compilation is success. So you also can create some rules, and if you are lazy enough to not view every step in the compilation, you can actually just print compilation success, and that's good enough to do it. So before I start to compile debugging, I actually advanced in this project, and I figured out that there is a problem in the Infix test analyzer, because we just have a typo here. This shouldn't be the first rule. It should be validate. Is validate, I think. Let me see. I think there is rule available. Let me see. Yes, it's rule available. I have this problem in previous occasions, and it's just a typo. This is the principal reason, one of the principal reasons to test your function before delivery to a colleague or a client. Yeah, see, it was very difficult to track this problem. No, it's not that difficult. Okay, let's compile it. Ooh, set out. We're not using the standard set out. We're using Qtext stream. And just enter to the breakpoint. Oh, sorry, forget. Okay, just hide this one. In the right section, we have our local temporal view of the variables that we're having in the current scope. So we can see actually the values on them. It's pretty useful tool. So initialization, you can see that it's changing in real time. So first step, get a lexem. And expanding this, we have that the first token is open bracket. You can see also here open bracket 4. The number 4 is the number actually. So it's not an end of line, it's not an end of file. So we're going through the file. It's not a semicolon, it's not a comment, it's not an error, it's not a close bracket, and it's open bracket. So continue. The next one is more cars, the first idea of our knowledge base. So the same stuff, but in this case, rather than the last one, we're going to push it to the token stack. So you can see here that we have already an ID, element ID called num_cars. You can also see that the tree index has a word strange value. This is because this is not the time to assign this number. This number is pretty important, so continue with this. The implication, we also need to push it to the token stack. Then the right operand, also push it. And when we reach the close brackets, we can just say we've already finished to see all the tokens of this rule, so it's time to create the rule. Next, just ensure that there is no any error in this case. We should check the token stacks, and as you see, for example, the first rule flag was true, so in this case we're going to enter in this part, and there is the building stack. The building stack has 0 items, so this is throwing an exception and access violation. In this case we're just skipping it and switch. What kind of type is it? The right token. So we can just expand this. It's an ID. Great. We should enter in this function and start stepping in on it. So we check the left token, that it's the another item that is in the rule. We determine that it's an ID. We create an atom in the build stack, and you can see left, it's 1. This is the part that we're assigning the number of the atoms of the nodes of the tree. Break it, and now if it's validated, if everything is correct, we can build the operation depending of the variable operation. In this case, an implication. So we just build it in. Let's see, left is 1 and right is 0. Okay. We push it in the view stack and token stack for further operations, and we start over again. Okay, let me just have a space here to explain what we did here. And actually I have this diagram of representing the tree that we are building. So you may say that here was the implication. Its number is 2. This is the number of the tree, and we also have an ID. Its index was 1, and we have another ID here. Index was 0. Okay, so this is the first loop iteration that we have for this tree, and you can see that even for 2 rules this is a pretty strange diagram. Imagine if we have kinda 2000 rules, it would be pretty cool to see this diagram. Usually will be just a pain in the ass. So sorry, let's continue with this. So the rule is semicolon, and we have a new situation. This first rule, what is going to happen is that we're going to enter into this if, and the builder stack has 2 elements, 0 and 1. So the tree, I think that I skipped it. Well, let me see. The tree, I skipped it, I'm sorry. But the tree is actually the index of a true node. And it's important, this node, because if we don't have the true node, the tree cannot be constructed properly. You will see in the diagram in the time that I'm going to explain it, but true is right here. So remember that any parent node needs 2 mandatory. It must have 2 operators. So if we, in the first rule, we need to have another one to create the parent. If not, we're going to have some errors and the persistent project won't work. So we create an operator, and AND, and we validate it. You can see that we have an element of the stack. It's actually you can see here, tree index 4, the token is an and we actually have to do this 4. Just bear with me. It's going to have more sense when we go through this process. So we're studying the next rule. Blah blah blah. Application. You can see here. More energy. And if we go out of that loop, we're saying that we finished with that rule. the operation. It's not the case. Let's see the left variable, and then where is it? What is it? I should. It's not the right. It's not there, but whatever. What happens when I do this? The left change. So the operation that we already have is that. It's an implication. So what we did here was that, let's see in the resource file, results, just spinning it. So we already verified this part, this rule in the compilation. So what's happening here? Just go to the tree. We're having that the first ID was 7 and the other ID was 5. And just have a quick eye here. The implication that is this guy has a tree index with a number of 7. So we have another index here, 7. Okay. So what's happening here is that this AND is kind of interference, a bridge between two rules. You may see in this way that any implication, any main operation in a rule, in this case the implication operation, has the leverage of be the node representing all below of the operation. So you have a few operations. I don't know. Let me see. For example, I have another operation here, or more enthusiasm. The completion will start with this rule. It's going to build the OR operation, and after that, it's going to think that this is a single variable. I build this one, and the parent operation will be this guy, the implication. So, just another reminder, when we are having a semicolon, we are creating a bridge between no rules, and this bridge can be represented by a AND operation. Okay, so we're almost finishing, so still calm. Oops. Okay, the completion was successful. Well, the last step was the, let me see, the Infix analyzer. The last step was to have the semicolon. So the semicolon say, okay, is it the first rule? It's not, it's false. So what's going to do? I can do this. Just to show it for you. Oops. This is because we changed this. Control Alt S. Just to simplify everything. Blah. 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 in the first semicolon of the first row. So if we type again F5, it shouldn't work. Hey, come on, dude. I'm waiting here. F5, F5, F5. Let's see. Just let me see which one we're using more cards. Okay, it's the first rule. If we type again F5, we already have 5, 5, 5. Just look at the 5, 5. More exercise, more energy. So column. Okay. So the last step, we already have the, let's see, in the diagram we have two children that are the implication and the and with the 3 index 7 and 4. So the last step is to join these guys and create a last node that is the one representing that the tree was successfully built. So we just said that the rule available is true, and we go in this way. We take all the right and left from the building stack that are ints. We create another operation to join the rules, and we verify that we are in the end of file, enters, check everything, and you might see here we have our parent node. It's the 3 index is 8 is and it's everything that we need to say. So the only way that we can go successful out of this function is returning true, and is that the xenol is equal to 4, the viewer stack size is 1, and the token stack is also 1. So we are already successful in this part. Blah blah blah. Compilation success. Okay. So that's it. It's pretty important. You would like to play around with this guy, and I actually recommend you to do your diagrams of the stacks to analyze any token, any element that you are having currently. I also recommend you to play with this diagram. It's actually quite funny, and you're going to understand everything if you do some grinding. So I think that's it for this video. In the next video we're going to show a new surprise. I think that it will be the last class that we're going to implement in the Pro compiler. We're going to start with the funny part, that is the user interface using Qt. I know. I think that the next step is to create the Infix kernel. That it's the main, the stronger part of this project. So it's quite it feels the enthusiasm here. Well, see you guys. Please remember that you can comment if you haven't have any question. Please, if you see that we can improve in some parts of the code, please let me know. See you to the next time. Bye bye.